will be 0. What we will do is we will push something like, let's say, we are pushing the data of fruits. So what we will do is we will push the, let's say we are pushing a strawberry, and what you will see here is we have created a new block here with the data strawberry, and there is a previous hash that is computed earlier. You can see the hash of the genesis block, that is 0000 DC, that is starting with, and you can find the hash here similar to that, and the hash of this block has also been generated, that will be used in the next block. So with this way, the security of the blockchain is ensured, the immutability. So if I'll change it to, let's say, mango, if I'll just push another block with the name mango, so what it will do, it will create another block with the data mango, and within a block in the real blockchains, there can be a number of data that can be present within the block itself, and that's how the things work actually in a blockchain. So uh, a block is there. Within this block, if it is a genesis block, the previous transaction hash will be 0, and it will also be having its own data, that is the cryptographic hash of the block transaction. And with the new blocks that are created, they used to have the information that is related to the previous transaction hashes and the current transaction hashes. So let's move on to the types of blockchains. So there are two types of blockchains generally: public blockchain and private blockchain. In the public blockchains are generally are decentralized, where anyone can participate. Means e- anyone in the globe can participate in the core activities of the blockchain network, and they do not have a single or a group of entity that controls the network and that can actually manipulate the system. So for example, we can have a bitcoin or an ethereum, where the the blockchain participants can be anyone. They are not restricted to a group or a a single entity. Coming upon the private blockchains are centralized and allow only a selected and the verified individuals to participate in the network. And based on their roles, they might have the power or the rights to override, delete, or edit the entries on the blockchain. Suppose it is a public blockchain, and let's say you have pushed a number of blocks on this public blockchain. So in the public blockchain, it is not that easy to like delete, override, or do something on the blocks, because we used to have this 51% consensus. That is a consensus model. There are a number of that is a 51 consensus model. Means if you are not having the majority uh, that are agreeing with you, then your changes will not be pushed into the blocks. And whereas if it is a private blockchain, then the things changes. Let's say you are having a genesis you are having 1,000 blocks and you want to change, let's say, 500 entries. You are a manipulative actor with the wrong intentions. In the private blockchains, if you are having the access, then you have the right to do so. So both have some benefits and some uh, what we can say benefits and other things. But for the private blockchains, there are surely advantages if you are looking for the systems like in the supply chain management. These are generally used by the organizations, and for that we have the hyperledger to do so. Coming upon the blockchain, the very first decentralized blockchain network that was created was Bitcoin, and that was created in the year 2008. An anonymous entity named Satoshi Nakamoto released a white paper in the same year and proposed the first ever decentralized blockchain network, a peer-to-peer network for the payment transactions actually. Uh, Coming upon the next. So why do we need the blockchain actually? So as to improve the transparency in the system, to promote a trustless, verifiable society, and for the traceability of the transactions and data shared across the network. So whenever something happens on the blockchain, if it is a public blockchain, we will from here we will be covering about the public blockchain and not the private blockchain first of all. So in a public blockchain, if something is stored on the public blockchain, then anyone can see it, anyone can verify it. The transactions are here immutable. No one can just change the code or change the data that is present within the blocks. So it is actually almost impossible to change anything within this, and that leads to the improvement in the transparency within the system and promote a trustless environment. And if let's say if there is a uh, corrupt person and he is doing something wrong, let's say he is having some black money and he is transferring from one account to another account, then anyone can verify it where the money is going from him to some other sources. So it the blockchain offers a traceability of the transactions and the data that are shared across the networks. Now the applications of the blockchain. If I generally speaks about the application of the blockchain, there are enormous amount of application that blockchain can offer. For example, instant cross-border money transfer. In the earlier time, means even today, if you have to transfer, let's say, uh, or you want to get the remittance, that is getting the money from the US or any other place into your account, then it's gonna take at the very least 4 to 5 days to get within your account. And with the blockchain you can get within an instant, within even a second, in your wallet. So that's the biggest benefit of having a blockchain network. Then coming upon the logistic, supply chain chain management. For let's say you are having a ship that is and that is having some food within that. So what will happen is you are transferring the food. Let's say it is a perishable food from let's say India to USA and via ship. So in that during that period of time, you can easily track what's the status of the ship, if it has been delayed, if it has reached or not. And you can improve the supply chain management, because you are not relying on any these centralized databases, and you are just relying on the blockchain that is publicly or privately available. In this case, private blockchain can also be used, because these are generally used by for the supply chain management. Generally, what we see is private blockchains are generally used for the grants and funds disbursements. So let's say a flood has come. In that case, you are transferring, let's say, $10,000 to your government's fund for the relief camp. So you want to have the transparency within the system, so as your money gets used in the way that you want. So with this blockchain, we can actually ensure that. Coming upon the other applications, there are banking and accounting. Then we have immutable certificates. Let's say you are having the 10th certificate, 12th certificates. These can be generally can be kept as a SBT. They can't be transferred. SBTs are soul bounded tokens, whereas NFTs are non fungible tokens. We might cover them today itself. Then record keeping and sharing. Let's say you are a decentralized science project, let's say, and you are having some research paper that you want to share with someone sitting in Russia or somewhere else in the world. So what you can do is you can just publish it on the blockchain or the data, and the other person sitting in the Russia can verify and check whether the content, the record that you have sent, the data you have sent is correct or not, and it is not manipulative by someone. Coming upon Bitcoin versus Ethereum. So Bitcoin is a distributed blockchain having a ledger. Means every transaction that will be performed on this blockchain will be kept on the blocks. Each block can have a multiple transaction within that. Whereas Ethereum is a Turing complete machine. So Ethereum complete is from the theory of computation. In the computer science, there is a subject called theory of computation. Turing complete generally means something. Uh, uh, if Ethereum is a Turing complete machine, then it ensures that anything that can be run, any program that can be run on the Turing complete machine can be run on the Ethereum as well. So it is a Turing complete blockchain with the capability to understand and implement digitally written agreements, which we generally call as smart contracts. So digital written agreements are the are generally known as are contracts where you can actually, like, what we can say, automate the tasks and can predict the outcome of those. We will be covering this smart contract within the coming slides. So let's roll over to the smart contracts and what are smart contracts. So smart contracts are program having a set of instructions. Programs are generally a set of instruction itself, and that these are stored on the blockchain network and are executed when the predetermined conditions are met to automate a workflow, allowing each participant to know the outcome without any intermediary involvement. Let's say let's say, for example, I'm a shopkeeper and I'm maintaining a ledger of yours, and you are just consumer. You are daily visiting, and I'm maintaining your ledger. And one day I decided to, like, be a manipulative person, and I changed some entries within the ledger that I am writing, the physical ledger. Then I can say that you have bought, let's say, 1,000 rupees of fries from me, but actually you have just purchased 500 rupees of fries with me. So in this case, a smart contract ensures that the things are well written. You can just have some smart contract that can be a shopkeeper's uh, let's say shopping smart contract, and where we can maintain the ledger itself. uh, Instead of having a Bitcoin, you can have it more into be a smart contract, or you can have a, let's say you are a freelancer and you are working, and the employer that have gave you the task has decided the milestone that he will pay after the completion of the 30% of the work, then 60%, and then 90%, and then complete payment. Then in that case, smart contracts can be configured accordingly, that if the condition satisfies, let's say you have completed the 30% of the task that was assigned to you, then you will automatically receive the payment within your wallet. Not If I call automatically, that is kind of a wrong, because EOAs are needed. EOAs are externally owned accounts, not smart contracts. In the recent With the recent development, that is the account abstraction EIP 4337, things can change, but these will be something that we uh, that is still in development, so I'll not be covering that. Coming up on the smart contracts languages. So smart contracts are just simple program and can be written in any languages as long as the blockchain that you are working on support that particular language. At present, if we talk about the smart contract languages, if you are working on EVMs, Ethereum virtual machines, then we have the Solidity as well as Viper. And for other let's say you are working on the Solana, then we have Rust. And for other networks, we can have Yule. Yule is also supported on the these EVMs, and there are also vast vast libraries. Means if you are writing a C++ language contract, and some blockchain that supports WASM, then you can also compile your smart contracts on those blockchain easily. So coming up on to get started with the Solidity. So there are so what we will do is, we will first of all, there will be two things. We can either for to run the smart contracts, first of all, write a smart contract, we need an IDE. And to get started for the beginners, it is recommended to use Remix, because you can easily test your contracts within this system itself. And for the advanced or the intermediate level, you can use other smart contract uh, development environments such as Hardhat, Remix, Hardhat, then we have Truffle, then we have Foundry or Brownie. Then you can use any of those for the testing purposes. So for these data types, I'll be covering here itself. So what I'll do is you can create another workspace. I have just created a workspace named uh, workshop, and workshop is created, and I've just deleted all the contracts earlier from this and created a sol file. What you'll need to do, every smart contract that you write on the EVM needs to have the ending with the sol.sol. It is the to so as the compiler know that it is a Solidity file that needs to be compiled. First of all, in any smart contract, first of all, you will need to have the SPDX license identifier that says which license you are supporting, your contract is supporting. Let's say you are having a MIT license, means anyone can copy your smart contract or can distribute it or modify it with other licenses, like let's say you are having a GPL, same things are offered. With BUSL, things changes, like you can't just copy the smart contract easily without taking the permission from the contract owner who have wrote the code. Secondly, as the Solidity is very new languages, I do have covered this in this also. So why do we need the pragma? So we need to always define the Solidity pragma, that is the Solidity version. So if I'm writing, let's say 0.8.16, so it is the compiler version which this file support. So being pragma is generally the second line, because the first line is always like the license identifier. Pragma is a directive that specifies the compiler version to be used for the current Solidity file. It is important as Solidity is very new language and it's subjected to continuous improvement on an ongoing basis. So you can find all the compiler version here itself, which compiler version you want to compile on. Let's say your contract is you want to run contract which is having the safe math implemented within those contract itself by automatically, then you'll need to have a compiler to be above 0.8, because above 0.8.16 or 0.8, all the smart contracts automatically inherit the safe math. Earlier, for the safe math, we'll need to import those safe math contracts within the Solidity file, so as to ensure there is no wrong calculation with the math due to the over what we say, if there is a limit, if we cross that limit, then the value gets changed to 0, let's say. And I can also I guess demo it to you what will happen if we are having a smart contract, let's say 0.7.6. It is a workshop, contract workshop function. First of all, let me just define event, let's say 16, I guess. Event 8 will be great. Event 8, let me just keep it to be private, and or let we just keep it to be public, and we will assign a value. We'll name it as num and assign the value to be as 254 for this demo, and increment, and it is going to be an external. And what we will do is we will increment the value of this, and instead of this, I generally recommend using plus sign instead of. You can either use this syntax, or you can use num plus equal 1, that is also similar to that, or you can go with num equals num plus 1, that is again same, and you can either opt for to have this syntax. These are all same. That is, this is pre-increment, this is just a normal syntax. It performs similar to this, and this is a post increment. Any of the syntax is gonna work. So what will happen now, I have given it to be a uint 8. If I'll compile it, just a second, what happened, I have, okay, I'll need to change the compiler version first of all here, so as to prove the safe math thing first of all. So I'll change the compile version here, and let me just deploy it. What will happen here, if I check the num, it is 254. If I again check the num, we have incremented it by 1, then the value should change to 255. That is okay. But now when I change the, when I call the increment function again, then what will happen is this value will change to 0, because uint 8 is going to have a maximum value up to 0 to 255. Why? Because you can also use this as a tool. It is going to give the value itself. It is because each it is going to be a mathematical one, I guess. So you are having, let's say, first, second, third, fourth, fifth, sixth, seventh, and eighth. Uint 8 will have 8 sections of these, and each one can have two values, whether 0 or 1, and the total number of values that they can have at max can be, uh, what we can have at a very minimum, we can have 0 0 0 0 0 0 0 and again 0, and that is gonna sum to 0. Other and otherwise, if we are having, let's say, 1 1 1 1 1 1 1 and 1, these are 8 ones, and if I calculate the sum of those, that is going to be at a maximum of 255 permutations. So 0 to 255 permutations are possible with this. So if I'll sum, it is going to be 255 and not more than that. How can you sum these? It is also pretty easy. With this, you will need to have 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4, 2 raised to the power 5, 2 raised to the power 6, and 2 raised to the power 7. That is going to be 128 plus 64 plus 32 plus, then we're gonna have 16 plus 4, yes, of course, uh, 2 plus, then we are going to have 1, that is going to give us 255. So this is something earlier to the earlier in the earlier version, we'll need to have we'll need to import some files. We'll also discuss it in the later stages, what is meant, what is generally meant by the importing a file, how it is done, and every other thing. But now let we just focus on another thing. Let we change it to 0.8.0, or let's say 0.8.16. Above 0.8.16, we don't need to care about these things, because these are automatically get done by itself. So I'll just need to change the Solidity version here. So I'll compile this contract again, and I'll deploy it again. Let me just delete the earlier contract and deploy it. So this contract has been deployed, and I'll just uh, read this again. First of all, what I'll do is I'll check the num value, that is 254. And then if I'll call increment, that is going to give me 255. And then after which it should give us an error. It is an automatic revert error. We do not need to write any special thing within our contract, because Solidity above 0.8 do include these feature automatically by itself. So having the latest version is also not recommended, but having the older version is also not recommended. So what you'll need to have is the widely used ones. You should generally use the widely used compilers that are recommended by the Solidity team, Solidity Fox. So now let's get it started with the, we have covered the pragma thing. We will cover the constructor later on, but let's first deep dive in the data types. So first of all, we are having booleans. So booleans are defined by the bool itself, and then we can have is true. And by default, the value of the bool function is kept as false. So if I'm having, let's say, bool check bool, and we are having an external function external returns. Okay, we will just we'll also discuss it on later stages, but I guess it's better time to actually do that. So what we will do is we can have a return statement over here also. We can return, and it is going to be a type of data type bool. So what we will do is we will return what's the stage of this bool, and if we want to change external view, because it's a view statement, I'll also cover what is view and uh, pure functions. But let's get started with update bool. If I want to change the bool value, so external returns and then bool, and again it is this time I will change the value of the is true to be as true. So what is being done here is the first one is the set. We can either call it update. I generally prefer to say it as set and get. So we can external, okay, external return bool. What the error it is giving us? It is giving us okay. It's giving us some error. Okay, we have forgot to actually return it. So it is giving us an error. Why we are not returning anything out of it? So okay, so it is a function named setBool, and it is an external function. That means it can be only called from not from the contract but outside the contract, and it returns a value that of data type bool. And the other function, and also what it is doing is it is setting the value of the bool is true to be as true and return it. The other function on the other function checks the value of the bool, and it returns well what is the value of that, because here we haven't defined also something that we'll need to see here. We haven't defined whether it is a public or a private. So by default it is private. So if I'll go here and if I'll deploy it, what will happen is I'll not be having any. Just a second, I'll need to delete this one and I'll need to deploy it. And if I'll check this time, I'll not be having any uh, any getter function for this is true, because it is by default private. By default private, and by default the value of the bool generally is for false. So bool values bool default value is false. And how can we verify it? We can check bool, because we have created a getter function for this. We can actually call it get bool, get is true or something as elsewhere. So we have got the value to be as false, and now if we set the value of it to be as true, then we can see the value has been changed to true this time. So for booleans, this is how we can assign, we can call, and we can interact with the booleans. And the second thing is integers and the unsigned integers. So in Solidity, we generally use unsigned integers, because unsigned integers are are the integers that works on the positive side, and the normal integers works on the negative side as well. So if I'm having u into 56, that means it will cover the value from the 0 to some other value, that is going to be 2 raised to the power 256 minus 1, the range of that one. And I can assign it to be as a public, and I'll say it as a num. And if I'm having int, let's say I'm having num2, so I'll create one more function, let's say set num, and external, and I'll set the value of the num. I'll need to pass value of this to be as u into 56. and I'll pass num. That is going to be I'll just set here, and that's it. And something that needs to be taken care of is in Solidity, you will need to have this these things after each and every line, mostly just like C++, if I'm correct. Set num, and I'll write a function for set num2 as well. So u into 56 and num2, and that is going to be an external function. So we can call it from outside the contract, and it is going to be num2, and that's it. Just a second. I guess I have done some mistake over here. Let me just check before I check the external functions at num2. I guess I haven't done any mistake. That is num2 u into 56. Okay, yes, see this. I generally use this term. That's why I forgot actually. So if I'll compile it, I'll delete. Just by pressing Control S, you are compiling the contract. You can check the tick mark of this. So I'm on this deploy tab, and I'll just deploy it again. So if I'll go this side, and if I try to set the num, that is a u into 56. See, it is an unsigned integer. If I'll assign negative value to this, it should revert actually. So let's assign this value. And if I'll call u into 56 set num, and if I'll call this num, it will give me 0 because -4 can't be assigned. If I'll assign, let's say, -255 or any other value, it again gave us error because it is not possible and the value is still remain to be 0. Whereas if I'll assign, let's say, some other value, let's say 200, because it is a positive integer, then this will work and the transaction won't succeed. And you can see 200 is there. Whereas if I want to set some negative value, if my contract needs to have some negative value, then what we can do is we can have int function, int. Then by default, to be remembered is if I am having uint, that is equivalent to calling uint to 56, and if I'm calling int, that is equivalent to calling int to 56. And if you want to have some other data type, let's say you want to store just a small data, then you can also specify it to be as uint 8, 16, 32. In the power of tools, you can assign the values, and that will store the value up to 0 to a maximum of 255 in this case. And in this case, you can store the value up to that is going to be a 0 to 2 raised to the power 256 minus 1. That is going to be the value that can be stored within this, and that is going to be a massive value, to be frank. So let's try to put some value here. First of all, for this set num2, so what I'll do is I'll transact, and this has went through, you can see. And if I'll check, it is going to give me the value here itself. And again, if I'll again demo it to you for the num itself, if I'll assign again it to be as, let's say, 100 minus 100, it should revert back. And if I'll check, it will give me the previous data that I have posted. So that's how you can interact with the integers, the unsigned and the signed integers. Then comes the addresses. So address, let's say it is a public one, and I want to store my user address, and function store my address, and that is going to be an external function, and that is going to store my address. So what I'll do is user address equals message dot sender. That is this message dot sender is something that is there within the Solidity. With this, you can get the address of the smart contract wallet, of the wallet that is interacting with this smart contract. And if I'll compile it, and there are also some other important that we generally use, that is block.timestamp. To get the timestamp of the current block, means each and every block, whenever it is mined, it is having a timestamp of it. And if we want to use the timestamp within any contract, then we use this block.timestamp to get the time at time of the mining. So what I'll do is, I have already compiled this contract. I'll delete this contract from here and I'll deploy it again. And what you can say is, if I'll see the address, by default address is address of 0. So 0x means this is a hex function, so 0x, and then the value is just 0. And if I'll store my address, so what it will do, it will just fetch the address from here, that is going to be 0x5b3 and ending with the DC4. So if I'll install my address, it has been called, and if I'll check, it has been changed to 0x5b3 and ending it with the DC4. So that's how you interact with the addresses. And coming upon addresses also, there's also one major fact: each and every address is unique by itself. Means if I am having any address, it is next to impossible that any other user can have such addresses. The probability of having it to be is in the very means 0 point something bigger. Then coming upon fixed point numbers, these are to be kind of in the early stages. We'll not be talking about these ones. We'll cover these enums and bytes as well as user defined. User defined are generally done by using a library. Let's say you are having a library which is defining the safe math library. Let's say you are having any library. Let's say for this, what I'll do is I'll just Google the library safe math and I'll import it just to showcase. So what I'll do is, instead of relying on importing, what I'll do is, here I'll create one more file, safe. Oh, my writing. Okay, yeah, I'll accept and I'll save it. So I can import this library. It is an import function to use the data that is been stored here. What I'll do is I'll call safemath.sol, and what I can do is, instead using safe math for event 256. So if I'm having this to be as, let's say, 0.7.16 or 0.7.8, and I'm having a, let's say, event 8 and public num, and this time I'll go a bit faster, function set num, and function set num, and what I'll do is external, and I'll set the num equals, or I'll just increment it just to showcase it to you, num equals num. And for, okay, in this case it will not work actually, because this is something that I have done wrong. I need to import your safe math for safe math 8. Actually, there are number of safe math libraries. It is a safe math for normal one. It's gonna work for you in 256. I'll need to have the safe math for safe math. Safe math event 8. Don't import that one. What you can do is, you can have this safe math here for the UN 256, or even I can change it here. itself, I can have this to be as UN 256. So I'll change it for, let's say, I want to add try add function try add, and what I'll do is instead of having it to be as this, I'll change it to 8, and similarly here, and for the testing purposes I'll do this, and this will work for the try add. So uint 8, and so this one will work for uint 8 dot add. If I'll call, then this function will be called uint 8, and again uint 8. Yes, I've already done the things that I need to do, that I had to do. So we are importing this, and then what I'll do is I'll set the value to be as 254, and this time instead of calling it as this, what I'll do is num dot add 1. I guess there's some error. Yes, I haven't changed the compiler version, so what I'll do is I'll change the compiler version to 0.7. I guess 0.7.6 is there, so I'll need to change the compiler version to 0.7.6, or we can also use this. It is saying that we can use any other version that is this or above, means you are having a version that is 0.7.6 or above versions are well supported if we are using the caret. If we are not using, then we are specifying that we are just using this contract. So if I'll compile, there is some error, I guess. It's still showing me some error. I'm not sure what error it is. Not found contract. I guess safe math is there. Oh, sorry for this typo. If I'll compile, it will again giving me an error. Okay, require different function. I guess yes, it is because this is 0.8.0. So what I'll need to do is 0.7.6. I'll compile again. What has remained? The expected primary expression in the safe math. I guess there is something that has been left here. Okay, they are using the unchecked parameter. I guess we'll need to skip this one. Unchecked has been included within the solidity after 0.8. So if I'll compile this contract with the 0.7.6, that will not work because we are having the unchecked parameter, and that only works with the 0.8.0 or above solidity contract. So we'll just skip this safe math thing for now. And to what we were on is we were on the user defined value type. We will just skip it for now. And for the enums and the bytes are generally used for the cache kind of a thing. If you are storing the hashes, then generally bytes 32, or like if you are encoding some data, then generally bytes 32 is something that we generally use. So that's that's how you use these kind of data types. Then other reference data types are mapping, and then we have also arrays. So mappings, array, and structs are there for reference. Mapping, array, and structs are there for reference data types. So for the mapping are kind of a hash table where you can look up if you have stored, let's say you want to store, if before storing, let me just if I'm having fruit and I want to store mango here, then whenever I look for the fruit thing, then I can find what is stored against it. And if I'm it is just a dictionary actually. In Python we call it dictionary, in other languages we call it hash map or mapping. That's how the things works. So how the mapping is initialized in Solidity is like you are having the mapping, and then you provide the data types that you want to store. Let's say I want to store the address, and against that I want to store something. Let's say I want to store the favorite number of the user. So address will get the user, and we'll store the addresses of the favorite number of the user. And for this, I'll keep it to be as a private, and I'll name it to be as my favorite num. And what I'll do is I'll create a function set my favorite num, and what I'll pass in is kind of a num, and then it is going to be an external, and it is also going to show me what I have passed, and external u into 56. Or what we can do, yes, it's gonna work. And what we'll need to do is we'll need to use this my map over here, and then we will need to specify what the address of the user. That is something that we can see from here. I guess I have got a message here. I'll just check if there's no message. There's no text. So message of sender equals the value that has been recorded here, and then what we'll need to do is we'll just need to return the value that has been stored. Either we can just return this value, or we can also return this value. That is going to ensure us that the value has been set. Yes, I have getting some text. Any text? Am I getting any text? Hello, am I audible?
Yeah, you are audible.
I guess I'm getting any text actually. Something is popping. I'm not sure. I'll just continue with this one.
Yep.
So let's see what has been. Okay, I'll just need to delete that one because that is going to give us an error again and again, because otherwise we'll need to change the compiler version for that. For this one, we will change the compiler version to 0.8.16. I have already shown why it is important to have a kind of a compiler that is not too early stage, or not too later stage. And not too later means the previous stages or the recent one. So we are just setting the value of here. Okay, we are also importing. I haven't deleted this line, so I'll delete this line, and then I'll compile it, and we are just storing the num. And then see, this time what I'll do is I'll deploy the contract. First of all, I guess I am having another contract. So what I'll do is I have deleted the earlier contracts, and then let's check on the value with this one. I'll, let's say, storing the value to be as scan for the set my favorite address. And here we can see it is ending with DC4. So I'll copy the address of this one, and I'm setting the value of this one to be as 10 this time. And let's say I'm also having some other contract. I'll call that contract also. So if I'll check the favorite address of this contract, so it should be 10 this time. And let me just call this, and it is going to show me 10. If I am having another account, let's say I'm interacting with this account, by default it is going to be 0, because by default the value that is stored within the u into 56 is 0. So if I'll call it, what will happen if I'll call the my favorite num, because it is a public variable, uh, it is having the public status. So if I'll call it public modifier, so if I'll call it, it is going to be 0 in this case. It is a public access. And then if I'll change this one to be as 5, and I want to transact, and in this case if I'll call it, and it is going to show me 5. Whereas if I want to, let's say now again wanna see what I have stored with my first address, if I'll call it, it is going to give us 10 again, because that has been stored on the blockchain. So that's how you interact with the mapping. And then with the array, you can, let's say you are having an array, you can also pass in, but what I'll show is I'll just show it to be as an array of u into 56. You can have any data type. First of all, you specify the data type that you are interacting with. Then you specify the this array block, and then you specify if you are interacting in the blockchain in the function, then you will need to specify what kind of it is. Is it a memory, or is it a call data type call, or is it a storage call? So for this one, what I'll do is uh, I'm having the array. So what I'll do is I'll pass in this value and I'll just show it to you. So what I'll do is I'll just delete these two lines and I am storing some values. Let's say my array. In this case, I'm not storing, I'm just returning the values this time. You into 56. What I'll do is I'll pass in two values or three values and I'll just return. We can also return multiple values. So in this case, I'll be having the multiple values to return. So u into 56, u into 56, and if I'll compile, okay. Oh, sorry for this. I have done this silly mistake actually. So first of all, what I'll need to do is we'll need to have this my array, and we'll need to specify what we are returning actually. In this case, we need to specify what we are returning. So let's say uh, all the indexes are generally start from the 0, so that's why we are putting the 0, and then we are having the 1, and we are just storing two indexes, so that's why this has been done. And I guess there, okay, one thing more, uh, which error it is. Functions at my function mutability can be restricted to pure. Yes, of course it can be, because we are not reading or writing any data to the blockchain, so we can have the mutability to be as pure and view, but I'll show it later on what these are and how these works. For now, we can these also, something that you will notice is it is not giving us a red error. If it is give red error, then we can't go and proceed with the contract compiling. But if it is a yellow error, we can proceed with it, or we can use the pure and it will go. That is as simple as that. But in this case, what I'll do is I'll delete the earlier contract and I'll deploy it again. And what I'll do is, in this case, I'll set, because it is an array, what we can do is we can specify the values here with a comma, and then we are having another value, and we will return these value here itself. So if I'll call this, so it will return us the value, that is 2 and 3, that we have stored, that we haven't yet stored in this. To be fair, we can store it u into 56, store public, store let's say num1 in this case, and u into 56 public, and that is going to be num2. And if I just want to store it, I can have it stored here, u into 56 num1. Oh, sorry, I'm redeclaring it this time. So what I'll do is I'll be having my array to be as 0, and then num2 equals my array of 1, and that's it. And I can return the value from here, and this time it will not be pure, because we are actually writing the data on the blockchain. So in this case, it will give us an error because it can't be pure. So if I'll compile it, it has already gave us error. If I'll just remove it, then it will work pretty well. So I'll delete this, I'll deploy it, and this time the transaction will work, and this time again the transaction will work, and we can set the values to be as, let's say, 2 and 6, and things are done. Set my favorite number. If I'll call it, we are getting the value to be num of 1 to be as 2 and the num of 2 be as 6. Also, we can have it to be as here. What we can do is u into 56, and then we can have it to be as let's say private or a public. Let's say for this one to be as public, and we can have it to be as stored my array this time. And what I'll need to do is I'll need to change this to be as my array this time, and it is also giving me some error. because I haven't used this my area. So what we can do is we can actually set, we haven't yet specified my array of 0. It should also work. My array of 0, in this case what we will do is we will just specify one value only, return, and what I'll do is I'll just return the value of this my array of 0. Also we can also have something that to be as a, it specify the limit, means the number of value that can be there within an array. We can also do that way, but let's see what is the error. Different number of argument in return. Yes, of course, because we have forgot to change this one, and this time it will work, and we'll declare it again, we'll deploy it, and we'll call it. If I'll now set my favorite, if I'll call this, I'll just need to enter one number, or we can pass in number of uh, values again, because it is not restricting us. We can pass, let's say, 3 and 5, and as the first element is 3, so what it will return is 3 itself. So if I'll call it, okay, just a second, it has given some error. Should be payable if you send money. I'm not sure why this error is here. I guess I've done something wrong. It should be payable. I'm not using any payable thing here. What I'll do is I can also specify, let's say I specify to be as 2, specify to be as 2. I guess I'm doing some mistake here. Public, no, control Z. I guess I'm doing some mistake, or what we can do is, in this case what we can do is we can just Google the things up for Solidity array, and in this case fixed size actually. So fixed size array, and we are just checking how we can do so. And here we can we'll just need to check where it has been defined. Yes, here it is defined. So that's how we can actually do so. So what we will do is we will get back to the remix side, and we can specify UN256 memory A, and in this case what is there is, it is having a length of 6. In this case what we can do is we can limit it to be as 2, and we can assign it to be as my array, in this case equals UN256 uint or UN256, that doesn't matter. And in this case it should work. Okay, I guess okay, something that I forgot is if we are having the memory, then we'll need to specify it within this one, otherwise it will not work. So that's how the thing works, and we can also remove this from here, and it will return the value. And why it is giving us an error, because we are not specifying any value over here. What we can do is UN256 A, UN256 B, and in this case we will just store the value over here. My array of 0 equals A, and my array of 1 equals B. That's how the things works, and then we can just return these elements out of this. Let's say I'm just returning my array of 0th, and that will return us the element that has been stored over here. And state mutability, yes, of course we are not changing anything. Of course, again we can change it to pure, that is not an issue. So that's how the things works for the mapping array. And for the struct, that is something different. For this, what we'll need to do, we'll need to specify the struct and name of that struct. Let's say we are calling it to be as my struct for this example, and then we can specify what kind of thing we want to store, what kind of data structures. The only thing that is also makes structs more powerful is that struct make it, a struct can optimize the values. Means if you'll have, if let's say you are having event 8 here, and you are calling public and num1, In this case, it will not be gas optimized. Actually, it will take the same space. When we deploy, we every contract consume the gases. So in this case, it will not save the gases. But in this case, if we deploy it using if we are having an instruct and we are having, let's say, num1 and uint50 uint8 again, then what it will do is it will compact. Means in Solidity, in the EVM, what happens is it is just a it is optimized for having the values up to 256. So in this case, it will compact this thing, otherwise it will not. And that's how the thing can be stored within the struct. And let's say in this case, what we can do is uint256 and one, and I can store number of different variables also. Let's say it is the uint256, and then I am having address, my address, and my favorite number, let's say. And how can we interact with the recent support? We can also provide this struct to be within the parameter itself, but for this case we will not be using that. And in this case, we'll just store the value over here. And we can also have the mapping. Generally with the struct, we generally used to have the mappings within that, and we are having the address, and we can have then my struct is kind of a data type that we have declared by ourselves. And we can have it to be as a public, and we can call it to be as my mapping. For now, I'll keep all this to be as my for now. Why I am using my lot, I'm not sure. Now what we will do is we'll call the my struct address, and it will store my mapping. Okay, so what we will do is we are having a mapping, and it will store the my struct thing. Okay, so what we will do is we will call my mapping of message of sender. Sorry for this. Dot. First of all, we will also need to initialize it actually. So what we will need to do is my struct, and then let's say it's a memory, and then we are having it to be as a my struct. And also something that we'll need to you should take care is that with the struct, we generally used to capitalize the first word. So we are having the my struct, and then we can call this my struct of I'm actually forgetting the how we actually do this one. For now, what I'll do is instead of this, this is how the things work for this. And if I need to change, check just a second for this one. I'm actually, my brain is fogging a bit right now. Give me a minute. I'll show you the syntax for this one also within a minute. So if I'll call any of this, and this is one of our contract that we have got. What I'll do is I'll just visit any of the file which is having this kind of a syntax, and I'll just show it to you. So we are having this to be as claims. So where I'll be calling. So I'll be having the idea how to do so. Yes, here it is. So first of all, we call the claim, then we store it. So that's how the things are called. Yes, of course. The only thing that I have missed is we are having this to be as my mapping, and then we will specify it to be as message of sender, and that's how the things works. And now what it will do is I can call my struct dot, because my mapping dot of message of sender has already been set, then I can directly call my struct dot favorite number. I can set it to be as the parameter a that I have set, and then what I can do is my struct again, my struct dot my address equals message of sender. Or say instead of this, I am storing any kind of a string. guess we don't need to specify memory here, but let's we do not need to specify actually in the string. So what I'll do is event 256. Oh, sorry. For this one, I haven't yet covered the string, so that is going to be a good moment for me to cover this one also. So a string memory, and let's say we are having any string that we are providing what I can name to be as name, and in this case, I'll keep it to be as a num. Num is much better than to be naming it as one. So we are having it to be as favorite dish, and what I'll do is I'll just copy it, I'll paste it over here, and instead of this what I'll do is I'll set the value to be a name, and then I'll not return anything this time. It's a public function and we can also check it using the using this side of thing. So I'll just compile it. Only thing that I'll need to check is everything has been set or not. What? Yes, of course it can be set to pure, because what we are specifying is okay, just a thing. In this case we will need to have it to be as a storage because we are storing it in this case. So this will now work. If I am having it to be as an like pure, then it can't be an storage because we are storing something within the blockchain. If I use memory in that time, I'm not storing anything in the blockchain, but I'm reading from the blockchain. So there are three type of things. First is storage with the structs with other data types like arrays. I guess arrays are there, and then with mappings, and with arrays and mapping we'll need to specify what kind of memory it is. Array mapping and strings, we'll need to specify what kind of data type it is. Are we storing it in the blockchain or we are reading from the blockchain only? So the second one is memory, and the third one is call data. So call data is something that is not generally used, and in this case if we are just reading the status, and we are not storing anything on the blockchain. But if we want to store, then we need to remove it pure from here, and we'll need to change it to be as a storage, and that's how the thing's gonna work. And what I'll do is I'll just delete this from here and I'll deploy it, and then when I look over here I can set these two parameters, and then I can check my mapping, and I can just copy my address from here. If I'll see now, it should give me what? It should give me, I'm having two things over here, the favorite number and a favorite dish. Favorite number will give me 0 because u into 56 default value is 0, and a string will give me an empty thing. So if I'll call it, you can see 0, and favorite dish is nothing because this is after this it isn't just an empty string. So what I'll do is this time I'll set the value to be as, let's say my favorite number is, let's say 65, let's say, for example, and my favorite dish is what I can say, let's say this time ice cream. In winters, ice cream, amazing. So I'll set these values from set my favorite, and this has been sent and has been recorded on the blockchain. Then what I'll do, I'll call the my mapping, and this time this will show me what I have stored on the blockchain. This is a also at the same time what I want to convey is that this in this remix we are running a local blockchain within this. You can say to be as a hosted blockchain. It is giving you a certain kind of accounts, and with those accounts you are just using them for the purpose of the transaction. Otherwise, if you are doing a real world transaction, then you will need to have some kind of a wallet with your account, that is going to be MetaMask or some other wallet, Rainbow wallet, any other wallet, Coinbase wallet, for example. And within this, you can have you can create an account. You will first need to have some kind of you will be having a 12 uh, 12 now 12 string kind of a what we say 12 string of secret key that you will need to keep it with yourself, and then you can create an account, and then you can interact with the blockchains with the smart contracts. and the dApps that are there. And now coming upon the other things, we have already covered all these things, I guess. Enums are just, if I can just write here, enums are declared like this, enum, and then we can specify anything, and that's how the things work with the enums. And now pragma has already been covered. Let's come on to the constructor. The constructors are a special one-time optional functions, means you can have it or not, that doesn't matter, and they are used to initialize the state variables of a given contract. And a contract can have a maximum of one constructor. You can't have as many as you want, and the code that is written within the constructor will only be executed during the contract deployment. Means whenever you will compile and run the during the runtime, during the compile time it will be compiled, and whenever you will deploy the constructor, that is a special kind of a function, will get called, and the whatever is there within this within that function, that will be called, and the function will be done, evaluated. So what we can do is, generally after, there are also like net specs and other things, so I'll also cover on those things, and then practices, the good practices. So I'm having the constructor, and what I'll do is I'll delete all these stuff from here for now. I've already covered these things. So into 56, and I want to set the num value, and this time I'll keep it as private. Sorry for this typo. And here I am passing uint256 num, and this time I am setting it or I should keep it as a public for now. And once it's done, it's just a one-time function, and if I'm having, let's say, set num2, I'll do is I'll control C, control V, and I'll call it to be as. You can also like use shortcuts like control C and control V. It will just copy and paste the things up. So that's how the thing. That's how you can take advantages of the shortcuts. Uint256, and then we can specify num2, and I haven't specified the type. So what I'll do is I'll call num2 equals num2, and that's how the thing's gonna work this time. Yes, it worked. So only the num can be set one time, and the num2 can be set multiple time, because we are having a function. Constructor can be called only one time. So if I'll deploy it, and if, just a second, there is some error, I guess. Currently you have, okay, I'm having a constructor actually. Okay, sorry for that. I actually forgot to enter the value within this one. So we'll need to pass the constructor value within during the time of the deployment of the contract. So I'll deploy it, and if I'll check the value of the num variable, that is a state variable, if I'll check the value, it is going to be 10. For the num2, because it has not yet been initialized, the value is still, it's going to be 0. But the thing here is I can't change the value of num, because it can't, the function, the constructor is special function, can only be called one time and not multiple times, and we can't just specify a number of time within the function itself also at the same time. So if I want to change the this value, it is common. So we have covered the constructor in detail, I guess. Now coming upon the visibility modifiers in the Solidity. So there are 4 visibility modifier. Actually, I guess yesterday I have done some, when I was stating about these things, I have done a mistake actually for the internal and the private one, I guess. I'm not sure yet. So for the public, if I am having it to be as a public, anyone can call it, whether the smart contract, this is smart contract, or using this, uh, or anyone, means outside the smart contract, I can call this function. If I am having it to be as, let's say, external, then what will be the case? Only the outside thing can call it. Means within the smart contract, I can't call it. If I want to call it within the smart contract, it will not work. That's how the things are. And the third thing, that is internal. So what happened in the internal and the private? I guess I actually yesterday did some mistype over when I was typing. So internal in this case, what happened is this smart contract and the contract that inherit it can call this function. But in the case of the private, only this smart contract can work with this one. So if I'm having, let's say, function set, I'm having this function. So what I'll do is I'll set it to be as a private, and it is a private function now, set num. And what I'll do is set num2. And this case, generally with the private and the internal function, we specify it to be as this underscore generally. So what I'll do is I'll set it again here, num2. This time I'll keep it to be as a public, or say external, and this time I'll call this set num2, and this will work, set num2, and I'll provide num2 over here, and it will work, and the value will again be changed for the num2 variable, and I'll just redeploy it. And for this, you will not be able to find set num2 here because it is a private function. We can call the set num2 because it is an external function. So what I'll do is I'll call it to be as, let's say, 20, and if I'll call it num2, value will be changed to 20. But as soon as I call it from other contract, then this function will not work because it is a private function. It can only be called within the contract itself and not outside, and not the inheriting itself. If I am inheriting this contract, then again it will not work. Then coming upon the special modifiers, then we can have the view and the pure. So these two have already come now. So what I'll do is I'll just explain it with an example. So let's just go on the theory part first. So what are view functions? View functions are those modifiers actually that can access the data from the blockchain. So let's say you have stored some data on the blockchain, and you are just want to access that data without performing any computation and changing state of the contract. Then you can use the view function, view modifier. And in case if you are not accessing any data from the blockchain and are just performing the computation without changing any state, then you can use pure. The best example for pure is actually we can have, let's say we want to perform addition, and we are just supplying num1. Okay, I haven't specified the data type this time. Sorry for that. UN256, UN256 again, and I'll call it to be as B external. And what I'll do is this time I'm just performing I am not using any data that is stored on the blockchain. So I'll return UN256. I'll just return something. It is local variable. It doesn't matter if you use local variable in the pure functions also. So I'll call it to be as sum addition equals a plus b, and I'll just I'll just return the value of this addition, and that's it. What I have done wrong, I guess I've done something wrong. Yes, I forgot to actually delete this line, and when I'll compile, it will compile, and then I can deploy it with, let's say, 10 this time, and I just want to perform the computation. And let's say I have it specified it to be as 1 and 4, and I want to perform the addition. It will give us the addition. And even if I'll not do this will again work, but it will give us a yellow warning that we can change the mutability to pure. In case if I want to use something that is stored on the blockchain, let's say I want to use this variable that is UN256 num variable, then what I can do is I can restrict it to be as view, and in this case what I can do is a plus b plus num. And in this case it should be view, and if I change it to be as pure, it will give me a warning that it can't be because I am reading the data from the blockchain. This is a state variable from which I want to read the data. In this case, what I want to do is we should change it to view, because we are not pushing any data on the blockchain, yet I am reading the data from the blockchain. I guess you got it. So what I'll do is I'll deploy it again. I'll change it to be as, let's say this time I don't want to go with the 10 itself. So what I'll do is I'll use 30 this time. So I'll deploy it and then I'll perform the addition, and let's say 34 and keep it simple. Keeping it simple, 20 and let's say 40. And if I'll perform the addition, that should give me 60 plus 30, that is going to be 90. That's it. So these have been covered. Let's come on the second one, that is the custom modifiers. So these are the modifiers that are intended to run before or after the function call. Means you can either run before the function gets executed or after the function has executed. So how they used to act as a security check to restrict the access to the given function. So let's say I'm having this function and I only want this function to perform when the a and b value, or a value should be greater than b. Let's say for this example, what I'll do is I'll keep it more, and also what I'll do is this time I'll store this variable going to 56, and what I'll do is I'll call it to be as num2 itself. So instead of this, what I'll do is I'll call it to be as num2. I'll store it as num2 external returns u into 56, and for that, first of all, modifier I'll compare is permitted, is the call permitted, so is permitted. And what I'll do is we can also pass in the parameters within the modifier also. So what I'll do is I'll pass in a and into 56 b, and what I'll do is require, these require are checks that the things that these value will be performing, a should be greater than b, otherwise the contract will not be called. Also something that we should take care is that if we are having this thing, this underscore and this, then on the after the lines of the code, then first of all the function will check this modifier, the condition, then only the function will be called. If we are having this to be on the top, then first of all the function will be performed, and then only this condition will be checked. So having it to be on the later stage is generally uh, effort, and that's how the it generally get used. So what I'll do is I'll change it, and this I'll use it over here, and I'll need to pass in the variables that is going to be a and b, and that's it. I guess I have done some silly mistake, I guess. uh, I'm storing the data, I guess. uh, is there something that I'm missing? Can be restricted to view, I guess it can't be, because I'm changing the state of the num to u into 56. I'm not sure why it is saying me this one to be as view. For them, I'll keep it to be as view only. It's gonna work. Okay, amazing. Yes, that's that why is it was giving us an error, because we were actually not doing this. We were using the u into 56. We were declaring it again and again, so that's why it was giving us an error, saying us to like use that one. So I'll deploy it again, and this time what I'll do is, first of all I'll show you when it will allow us and when it will not allow us. First of all, the time when it will not allow us, let's say I'm having a to be as 20 and b to be as 30. In this case it should revert back, because what we have done is this condition is not checked, has not been verified. So this function will not be called. But as soon as I change this value to a to be as 40, sorry, then the function will be called, and the value for the num2 will be set, and the value will be what? Value will be a plus b plus num, that is going to be 40 plus 30 plus the value of the num, and that is the value that we have initialized it with. So if I'll check the value, that is going to be I guess num2. Okay, num2 is the value that we have to check. That is going to be 40 plus 30 plus 10, that is going to be 80. So we have covered the modifier as well. Then coming upon the constant and the immutable state variables, these are a special kind of state variables. Why? Because whenever we compile the contracts, these are stored within the contract itself. Otherwise, everything is stored on the data. In this case, these things are stored within the contract itself, and you can use it anywhere. Means like literally constant. For constant, what I'll do is event 256 private. This time, let's say keep it a public again, constant, and let's say I want to store pi value equals 314. 3.14 is something, 3.14 is, but in Solidity we can't use the floating points numbers, so I'll keep it to be as 314. And function, what I'll do is uh, get pi value, and in this case it will not it is just a public function, it will just give us the value. But showcasing you the other thing, that is the immutable thing. So what we will do is you will create other data type that is of immutable nature. Immutable variables are those variables that are needed to be initialized in the constructor itself. They can't be later called on, so we will need to initialize it also. And for the constant, we generally use the caps words. We generally don't use like these uh, these words. Small caps, we generally do not use these, but we generally go with the caps words. For the immutable, same thing we can do. And for this, let's say fave number, and fave number can't be initialized here. Something that you should take care is that if I'll initialize it here, it will give me an error. I'm not sure why. Okay, yes, of course. The constant and immutable can be initialized here itself, but the thing is they can't be later on called in the function and changed. The value can't be changed in the function. If I'll try to change the fave num, then it will not work actually. Of what I have done, set fave num external, and let's say I want to call fave num equals 8, and it will give me an error because this is an immutable variable. However, if I am having a constructor, then this will work, and I can call fave num, and this value will be initialized to whatever I'll state, let's say 8. And if I'll comment, for commenting, what we can use is we can use control and the question mark, that is there, that is this arrow, and this will comment out the lines. If I'll be having this constructor, then it will work. It will compile successfully, and we can deploy it again. Can have the variable here. That's how the thing works. Then coming up on the next thing, that is the interfaces. Interfaces. Okay, I have forgot to like have the state variables that can be declared as constant or immutable. In both the cases, the variables cannot be modified after the contract has been constructed. Means whenever you have deployed the contract, then you can't change the any value within those constant and the immutable state variables, and they are stored within the contract itself. They are not stored on the blockchain. Like literally means if you are calling any function, then uh, you are like calling it from the blockchain. In this case, they are stored on the network, on the contract itself. For constant variable, the value has to be fixed at compile time. Means while you are compiling, while you are writing the code, you will need to specify the constant variable itself. For the immutable case, the value can be assigned at a construction time, and that will be initialized when the contract constructor will be called. So that's the thing. And coming upon the interfaces are created using the interfaces word. Solidity contract interfaces is just a list of function definition without implementation. That means that whatever we do in a interface is just a function definition, and we are not writing any functional means operation within those function. We are not writing any set of data within those function, and what it is used to do is to enforce a defined set of properties and functions on a given contract. So for this, what I'll do is I'll create an interface. Generally for these things, what we generally used to do is we I'm creating an workspace. So I have already have this interface file. So what I'll do is, instead of this, what I'll do is i'll I'll have it over here only. I'll have it over here, and I'll create it. Generally it starts with capitalized I, and I'll call it to be as workshop iWorkshop.solve. And what you can do is, first of all, you will again need to specify the SPDX license identifier and the pragma. That is important even for the interface file. So in this case, if you'll notice, for the contracts, we write it with the word contract. In this case, we'll write it with the word interface, and iWorkshop is just a workshop one. So what we will do, let's say we are having function num, and we are having it to be as an external, and it returns uint 256. So we have set it, and now when we import this, then the magic will happen. That is workshop workshop. Okay, I have mistyped again. Workshop dot solve. And now when I'll use this function here, I'm restricted to use this one. If I'll use this, I'm here using this iWorkshop. I'm deriving this contract. I'm using this, I'm driving this contract, and what I can do is, now I can, if I'll call this, let's say I'm calling, and also by default we'll not need to write anything like it. By default, interfaces are external. You can't change it to be as public or internal or something like that. It will give us an error. That is something that you should take care firstly. And without even any visibility modifier, you can't just keep it like that. You'll need to specify external, and that will work. And what we'll need to do is function, and then we can specify, let's say num, set num. Okay, we are having it to be as num. So what I'll do is I'll change it to be as set num this time. So I can have a variable named num and set num external. And something that you should see here now, because I have a return type here, I am restricted now here. If I use override is something that we are specifying, that we are overriding this, that we have inherited, that we have derived, inherited this. We have inherited this iWorkshop contract interface. Then if we override, then will got an error, because we are returning the variable here. We are returning the u into 56. So when we will do this return u into 56, then only it will work. So what we can do is, now return, let's say, even if I'm not saving any word, it will compile. Just a second, what I have done wrong. Am I taking any parameter here? Function set num external returns u into 56, and let's say, what's the error here? But got return. Okay, return u into 56. Oh yes, I forgot to have the s. So yes, that is pure. I'll not take care more about this pure and view. You can have it or you not have it. That is your choice. For now, even what I'll do is u into 56 public and num, and this will work actually. we can have it to be as num, and let's say it is going to be num, and this way the error can be into 56 num, and I'll need to specify why it is giving us an error again, because it has restricted us without any parameter. If I'll specify the parameter here, then only it will work. I'll specify here, and if I'll compile, it will work like magic. It will not give us an error. It is just saying you are returning any variable, but you are not here. So what I'll do is I'll return the variable, and it will compile successfully. That's how the thing. That's how you can do it. And now coming up on the next thing, I guess I have covered all these things here. Now what we can do is uh, we still have some time left, I guess, and we can cover any other things like I guess for this, or we can just run it. I guess we can just run it. There are other things like there are a number of things that we can also go in detail. That is data calls. There are call, delegate call. These are low level call and generally are avoided. You all can read about these things. Other than this, what you can read is catch-up 256 and about these functions are one-way functions. They are not two-way functions. So you can read more about these functions like catch-up 256. Catch-up 256 is the hash function that is used in the Solidity itself. And for the Bitcoin, it is, if I'm correct, I'll need to check actually. I have forgot right now. Bitcoin hash function. So you can just check it. Hashing algorithm. It will tell you. Shaft 256 is their algorithm, and also for the Ethereum, they also use one more hash function itself. So catch-up 256, you can read more about this. With this, you can actually encode the data with this function, and you can make it more difficult for the other users to see the data. It kind of give you a layer of security. Generally it is used for the security purposes. Cryptography in a way itself give us the comfort of the security. So catch-up 256 is something that you can read more. Then you can also read more about the consensus, and other than that, you can deep dive more in deploying the contracts on the smart on the these using the wallet. So what I'll do, yes, that is going to be amazing. So what I'll do this time, I'll deploy it using the MetaMasks this time. So what I'll do is I have compiled the contract already, I guess. So these two are not necessary here. So what I'll do is I'll just delete constructor fav num is not needed. I'll delete and I'll compile it. And this time what I'll do is instead of deploying it on local blockchain, what I'll do is I'll deploy it using this uh, using the wallet. So this time what I'll do is I'll switch to, let's say, Ethereum Goerli, and let me just check. I do have the balances, and you can change the environment to injected provider MetaMask, and that will show you the balance of this from here. You are now interacting with your wallet using your wallet, so it is showing you the and also see one more thing. It is saying that it is not connected to your wallet, so that means some other network is connected right now. And if I'll see, that is going to be this network, I guess. It is connected. So what you can do is you can just click on this and disconnect this account from whichever your account you want to connect. And you can go and you can click on this. Sorry, you can click from here, and this will pop up, and you can just select the network whichever account you want to interact with. So I'll select this, and now it will show me this address. And what I can do is now I can deploy it using this on the real on the test network. So I'm deploying it on the test network now. and this has been called the pop-up open, and then you can just deploy it on the real blockchain, and it has been called, you can view it on the Etherscan, the goal Etherscan, and let's just wait for it to get deployed. Yes, I guess it has already been deployed, and now we can interact with this. We have got the interfaces for it now, and yes, we can set the num value. It is going to be 0 because by default the value is 0, and we can set the num to be as something whichever we want. Let's say we want to set it to be as 10, and we can call again, and it will pop up because it is a real transaction, so it will consume some gas. It is the gas that we are paying. So when I'll call this, it will again be called on the Etherscan, goal Etherscan, and this transaction will be deployed in one of the block on the Ethereum goal network. So just let's wait for it to get indexed and deployed. In the meantime, you can also like read more about EIPs. EIPs are much important thing. You should also read more about EIPs like EIP 712, that is for the signature and signature, EIP 4337 for account abstraction, like, and 2612 if I'm correct, EIP 2612. Yes, EIP 2612 is for the permit signature. So there are, whenever you are having a tokens, then you will need to approve the token before doing any transaction with the permit. What you can do is you can clearly avoid those approval, and you can use the signature verification instead of using the approve function. So you can go with this EIP 712 4337 2612, and you can also what we can do this time, I guess we can actually, we still have I guess 45 minutes. One thing also to be noted is, generally if you are working if you are a software developer, you should use uh, I guess Ubuntu more. Ubuntu is more preferred, and you should get more familiar with the terminal using the commands. So what I'll do is I'll show you other things like desktop, and then let's say I want to create a directory, let's say workshop, and then cd. So this command actually, what it does is it creates a directory for us, and then we get cd into that directory itself within a single call. So what I'll do is I'll click code dot, so it will open the virtual studio code for us, VS code in short. And what we can do, there are a number of ways you can means interact with the you can write a contract within the VS code, and can write the test cases within the VS code, and interact with the blockchain. So there are a number of hard smart contract environments, development environments, such as solid I'll just write it over here, just give me a second. So these are hard hat, and you can have truffle, then you can have either brownie and for foundry. So hard hat is a JavaScript one. Again, truffle is also a JavaScript one, and for the brownie, it is a Python based. And as much as I know, foundry is based on the Solidity itself. So these are the languages that they are based on. So when you have created this one, so what you can do is you go to the terminal, and you can, if you are initiating a, let's say you are using the brownie, then what you can do is you will first need to install the brownie, and then you can call brownie init, and that will create some empty folder for you that is built contracts, where you can write the contracts and then interfaces, and then you can write the scripts for the testing purposes, and the scripts for the deployment and the testing as well as, and test. You can write the test here, and you can check whether the contract is working as you want it to. And for the help, what you can do is you can call Brownie help, and you can view all the things that are there. Brownie itself like give you a number of commands like accounts by itself, and you can use those. And also you can run console within this by calling Brownie run console. It is not yet running because I'm not having any contract here, that's why it's not running. And other than that, you can use accounts to get the accounts. By default, Brownie runs a local blockchain within this, and you can get the account to test to locally test your contract. Then you can run test to run the tests. That's how the things, that's how you can interact with the Brownie. And if you want to interact with the JavaScript, let's say hardhead, then you will need to have yarn, first of all yarn in it, and then you will need to install the hardhead by yarn add or npm add npm install, sorry, npm install, and you can add the hardhead, and you can then yarn hardhead, and then after that you can interact with this. In this you will need to have hardhead.config.js, that is the important file for here. And then you can also deploy. Here we are using the hardhead deploy, that's why we are having this deploy folder. uh, Also tomorrow what we will do is we will cover these contracts that we have written over here, so as to showcase what are the things that what are the advanced things that we are, that you can know and can get more better in the Solidity contract development, Solidity smart contract development. And this is something that I was earlier talking about. These are the licenses for BUSL. Uh, if anyone want to use these contract, then first of all they'll need to take the owner permission to use this contract. If I'll change it to MIT, then anyone can use this contract, and it is free for use. Then Pragma Solidity is, it has already been discussed. Then these are the net specs. What you can do is you can just visit Google, and you can type Solidity net spec, and it will show you, sorry, net spec, sorry, my bad, net spec. I have done that. So you can find the documentation of here on how you can like document your document your code. So that's how you document your code. And then after which, I guess, something, these are the import, we have imported the interfaces, then we have imported the contract itself within our code, and we are inheriting it. And then we have initialized these are the tokens. So this is the data type of U256, and this is the data type of the token, that is the IERC20 upgradable. So we are having the upgradable contracts. Also you can at the same time read more about these things. There are three types of upgradable contracts. First of all, you are having firstly you can go with the transparent proxy, and then second of all UUPS proxy is there, and the third is diamond facet proxy. These are the three proxies that are generally used. So why we use these proxies? So whenever we deploy any smart contract on the blockchain, it is immutable. We can't like delete anything from the blockchain. So what we do, we separate the implementation from and the contract. We separate the state variables and the implementation. So we use upgradable contracts and separate implementation and the state variables. So what happen is, if we are separating the implementation and the state variable, then what happen is whenever we are calling it using the proxy, so proxy will be having the state variables while the implementation will be the contract. So there will be three contract that will be deployed when we will deploy a proxy. First of all, an admin proxy, then the implementation is the contract that you have written, and the third one is the proxy will be having the state variables that you have written. So and in that way we can actually upgrade the contract later on. Let's say I want to have a new function to be included within our contract. So what we can do is we can deploy one more contract inheriting the older contract, and the state variable will, as the state variables are stored on the proxy. So there are three contracts that have been created. First, the implementation that we have changed, and the proxy will be having the state variables that were earlier called. So you are storing the data that you earlier had. So that's how you can upgrade the contract while ensuring the immutability of the smart contracts, because whenever you are deploying any smart contract on the blockchain, you can't change it, you can't delete it. Also you can self destruct it. There is a function for that also. You can also go through this also, self destruct. But even with the self destruct, what happen is you are just avoiding anyone to call those functions that are there on the block, that are there on the contract. But the contract will still be there on the blockchain, and anyone can view whatever the transaction that you have made with those things. So yes, these are the things that I guess I do have covered a lot today. And tomorrow what we can do is we can just have an overview of these contracts that we have written, or we can either go with the Aave contracts or some other contracts, and we can like uh, go through those. uh, over to you. Over to you, my friend. Hello, am I audible?